Hey, 20-1s. In this video, what we're going to look at is we're going to go back to grade 10. We're going to do a quick review of radicals, what it means to be a mixed and entire radical, and then we'll jump into grade 11 and we'll look at adding and subtracting these things, which is actually fairly easy. Okay, since we're in a new unit, let's talk about what is a radical again and why do we care? Well, simply put, a radical is when we're using this notation here, right? And what you need to remember are the pieces to it. So what goes underneath the radical is called the radicand. And what goes in kind of this little nook here, even though you don't see something, there's really a 2 there, and it's called the index. Now, in general, we don't write the 2 just because mathematicians are lazy. When we will start writing an index is when we're doing anything else other than square rooting. So if I was cube rooting, I would put the 3 there. And if I was fourth rooting, I would put a 4 there, and so on and so forth. Now, why do we care about these things? Well, the big reason is that we really don't like to round. Okay, I don't want to say that the square root of 2 is approximately 1.414. I really don't want to say that. This is an irrational number. It goes on forever. So we use radicals when we don't want to round. Okay? And rounding causes big issues, or it can. Um, I mean, here's an easy example. If here's us and we're on the Earth, um, at one point NASA was sending a probe out to, I believe it was Mars. And this probe probably cost millions and millions or billions and billions or something. And they were trying to land it in the orbit of Mars. I think it was Mars. And they missed, just went pow right past it, gone forever. Why? What happened? Well, you had two sets of engineers in two different places, and one set of engineers was working with metric, and the other set was working with imperial. And there was an issue converting between the two. And so when you start rounding numbers or truncating numbers like that, you're going to end up with issues when we start talking about really large numbers. Okay, so why do we care? Because we want exact values. So whenever you see that term exact value, you know you're expecting a radical without no decimals. Okay, before we go on, let's go back. And one of the things that you should really know are your perfect squares or your perfect cubes, which are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. And we know this list keeps going on, but usually if you know up to 12 squared, you're good. And your perfect cubes, well, your perfect cubes, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, and so on and so forth. Okay, you should have those things. Like you should know those when you're doing your mental math. Now, why do we call these things perfect squares and perfect cubes? That's also something that's interesting because they make squares and cubes. So when you're square rooting, what you're doing is you're finding the side lengths of the square. And when I ask you to cube root, you're finding the side lengths of the cube, if you had never thought about that before. Okay, let's go back and do some 10C review here. So it says convert the following to mixed radicals. So right now, this is an entire radical because it's entirely underneath the radical sign. The radicand is 72. So what we're going to do to simplify this is I'm going to say, what's a perfect square that's a factor of 72? Well, I'm going to find the largest perfect square, which is 36 times 2, just like that. And the square root of 36 is 6, so it's 6 root 2, just like that. What about the next one? It's a cube root. Well, now I'm going to look at my perfect cubes. So I say to myself, what's the largest perfect cube that's a factor of 72? That sounds like 8. 8 times 9. And the cube root of 2 is 8. Now, I made a mistake on purpose. I'll see this quite often. This is wrong, what I've written here. What I'm missing is the index of 3. If you don't write that index of 3, you're telling me you're square rooting when this question is actually cube rooting. Okay, there's a little quick review of 10C. And let's do just a touch more. Let's go the other way, which isn't as important, converting to entire form. So to convert to entire form, we're just going to reverse engineer what we just did. We want to get this coefficient of 3 underneath our radical. So the inverse of square rooting is squaring. And I'm going to go 7 times 3 squared, which is 63. So all we're doing when we go to entire is we're moving that coefficient in, and we're doing the inverse of whatever the function is. And the function on this case is cube rooting. So I'm going to go 4 times 5 cubed. And 5 cubed is 125. And what's 125 times 4? Sounds like 500 to me. There it is. Okay, so going to entire isn't as important. It's the other one here, converting to mixed. This is much more important. The reason why this is more important is this is putting us in simplest form. When we have the smallest radicand that we have, we're in simplest form. Why is it so important? Well, it's so important because that's what we need to be able to do to add or subtract radicals. Okay, radicals adding and subtracting is like adding and subtracting polynomials. I can only, if I was thinking of a polynomial, I can only add and subtract like terms, right? And what I would do is I would add my coefficients together, and so I'd get 3x, and I can't do anything with the y. We're going to do the exact same thing here with radicals. So the only way we can add radicals is if they're like terms. What makes them like terms? If the radicands are the same. So I look at this first question and I say, nuts, I can't add it. I've got a radicand of 20 and a radicand of 45. I can't add it yet. So what we'll do is we'll simplify this. So we'll look for our perfect squares that go into 20, 4 and 5. I look for my largest perfect square that goes into 45, 9 and 5. Square root of 4 is 2. There's my email going off. Square root of 9 is 3. And remember, what we do is we go 3 times 3, like that. So this is 2 root 5 plus 9 root 5. And so now we can add them because you see those radicands are the same. 11 root 5. Again, the only way we can add is if the radicands are the same. That's it, friends. That's as easy as this is. Subtraction is the same. So what you should really have memorized here, friends, is you should know your perfect squares and cubes. You should practice simplifying these things mentally without using a calculator. It'll save you time. And then to add or subtract anything, the radicands must be the same. That's it. See you next time.